So in this particular video, I'll show you how to attack a couple of different multiple choice questions that I found via the World Wide Web. Here we have a block, we have two blocks, M and 4M, that is being pushed to the right side of the screen. And it says that the system is frictionless, and it wants us to find what is the force causing the acceleration of the more massive box. So by using common sense, this is M, this is 4M. The more massive box would be the box on the right, which is 4M, but it wants us to find the force that's causing this system to accelerate, or excuse me, this 4M to accelerate. So it's important that you recognize that the force that's causing 4M to accelerate is not this force here. It's actually the contact force between M and 4M, because while the diagram shows you F, this particular applied force only touches the block that's labeled as M. It does not physically touch the box that's labeled as 4M. So what's causing this 4M to move? It is the contact force, or the normal force in the horizontal direction here for the block M onto 4M. So I'm going to go ahead and draw that out here real quick. So that red arrow that just came up is the contact force, or the normal force exerted by M onto the block 4M, which will cause it to accelerate. Okay, so therefore I just go ahead and label that F of M on to 4M. So the M subscript is first, and then on to 4M, which is the second subscript there. All right, so in order to do so, since it asks us to find this Fm of 4M, I can go ahead and just look at the block on the right. I'm going to focus my attention here on the block on the right, because that's what the question is really emphasizing. So therefore, Newton's second law would suggest that is force equals mass times acceleration. But what is the force that's causing this 4M to accelerate? It is the contact force that exists between these two blocks. So it would be Fm onto 4M. So you notice here in my statement, I have Fm onto 4M, which is equal to mass times acceleration. But what is the mass that I'm interested in? It is the block on the right side of the screen, which is 4M. So instead of writing M, I'm going to call that 4M, and the acceleration in the horizontal direction. Okay. However, I don't know what AX is, but what I can do is look at the system as a whole. Why this F is applied to just M, it's actually going to push both the blocks. So the sum of the blocks would be M plus 4M. So here in my work in black, it says net force of the system. Well, net force of the system in this case would only be one vector, which is drawn here, which is called F, that's pushing to the right. So instead of calling sigma F system, for this particular diagram, I only have one force, and that force is called F, and it's in the positive direction. Well, how much is that F pushing? Or it would be pushing a total system. In this case, it would be M plus 4M. So instead of M total mass here, I just replace total mass with M plus 4M. So you notice here I use parentheses when I substitute. That's just to keep my masses all together as one. So therefore, it would just be F equals to 5M times AX. M plus M is 5M. What I'm missing up here that I've highlighted in yellow for you, just to kind of help you keep track of what is the missing variable here. I don't know what AX is, but in order to find AX, I need to set up the whole entire system. But it's just the force F, but that force F is pushing a total of 5M, whatever M is. So in order to find AX, I need to divide both sides by 5M. So therefore, I have this statement. AX, whatever the horizontal acceleration is whatever force is divided by the total mass, which is 5M in this case. Therefore, I can carry down my work in the previous statement in red. Therefore, the contact force between block M and block 4M can now be substituted in. So the mass that I'm interested in is 4M on the right, but I don't know what AX was initially, but now that I found it using the system, I know that the AX value or function is F over 5M. As you can see here, M's will cancel out because I have an M in the numerator, I have an M in the denominator. So that's going to cancel out. So I just reduced it just 4M on the first parentheses times it by F over 5. So it'll be 4 times F, which is 4F divided by 5. So therefore this statement looks like choice D. Okay, so that'd be my answer for choice D. All right, so let's go ahead and crack out the next example. The next example here's a system of 3 blocks, 2M, 5M, and 10M. And the problem sets that it is pushed across a frictionless surface again. It says when we compare the normal force I want to point out that it says normal force here, but really it's referencing the contact force between the blocks. So it says P1 that M2 exerts on M5. So here's my first arrow. Since it specified what the variable is, that first arrow, I'm just going to call it P1 because it says the normal force P1 that M2 exerts on M5. So M2 is going to push M5 to the right. And what is that force called? That's just called P1. And then it says with normal force P2 that M5 exerts on mass 10M. Well, 10M is going to move because M5 or 5M here is going to push it to the right. So therefore, I'm going to draw my second arrow here. So my first arrow is P1. My second arrow that was not given to me, I'll call that P2 based on the wording. Again, once it says the normal force in this particular problem is the contact force, P2, that mass M5 exerts onto 10M. So 5M is going to push 10M. That's P2. And it says, which of the following statement pretty much is true. So I'm just going to use common sense and select choice D. Okay? Because if you look at it, the force here, F, is pushing 2M, 5M, and 10M. So therefore, it's pushing the whole entire system. So here I have F equals ma. What force? The F. What mass? The total mass, because it's pushing the entire system. So I have 2m plus 5m plus 10m times the acceleration. I don't know what the acceleration is, and I don't really care what it is because it's more of a conceptual question, okay? If you set up for P1, though, P1 is only pushing 5m and 10m. So here, in my second statement, I have P1 is equal to 5m plus 10m AX. And then last but not least, I have P2, but P2 is only pushing the 10m. Okay, so P2 here, my work is equal to 10m times AX. Well, using common sense, they all have the same acceleration in these functions. Therefore, if you look at it using common sense, the first statement pushes the most m. So in order to push more mass and have the same acceleration, you need more force. Okay, so I'm going to go with choice D here. It says that F is greater than P1, which is greater than P2, which makes sense. F is the farthest left. It is pushing the most mass. In order to keep the same acceleration, it has to be the greatest. P1 falls in between F and P2, so P1 is only pushing 15m, while P2 is only pushing 10m. Well, if you push less mass, you need less force. If you push more mass, you need more force. So for this particular problem, but just by using deduction, I'm going to go with choice D as my answer. Okay? All right. I hope that helps. Stay nerdy. Don't be whack.